Practical application of advanced photovoltaic cell technology in sustainable urbanization field. Abstract: the energy crisis is considered one of the most important concerns of the world now, because it has a direct impact on the economic of countries, and the extra advantage in the consumption of land resources from non-renewable renewable energies has a negative return, whereas on the environment through harmful emission resulting from the consumption of these resources. There is also a big problem facing many cities in the world, which is the phenomena of climate change and the phenomena of global warming, the greenhouse, and the dangerous environmental effects that follow. Research problem. The main problem that the message discusses in the high costs of solar cells. Although this technology has proven successful in generating electric power, many people are relocating the acquire them because of the high cost. And if it is possible to reach modern technology technique to reduce the cost of making these cells, we will have achieved many goals. One, low energy costs, which is one of the most important concerns of the world now, because of its direct impact on the economic of countries, as it is one of the most important problems facing countries, especially developing countries, as energy requires multiple fields in the area of daily life and affected by many segments of society. Two, also, with the success of this industry and by entering many sectors in this industry, including the governmental, private, and individual sectors, we achieve abundant job opportunity in this industry. Research objective: employing nanotechnology techniques for developing solar cells to generate electric energy to reach higher efficiency solar cells at the lowest costs so that the largest segment of society benefit from it. How to align integration of solar cells with building so that they give an aesthetic and functional value without affecting the architectural characters of Arab building. Attempting to come up with methodology for applying solar energy exploitation in the field of urbanization that aim to adapt energy sources in operation building on solar cells that integrate with building and give more than functional, aesthetic, and economic benefit. Finding design and technology solutions for how to integrate solar cells with building. This slide shows a different available technology of photovoltaic cell: crystalline silicon, monocrystalline silicon, polycrystalline silicon, thin film, amorphous silicon, cadmium toluene, copper indium gallium, compound semiconductor, light absorbing or organic photovoltaic, nanotechnology CPV. This slide shows the grade of system of integrated photovoltaic cell. Photovoltaic power generation in the building integrated photovoltaic BIPV. Building integrated photovoltaic BIPV, residential building, infrastructure building, industrial agriculture building, commercial and office building, and public building. This slide shows how can photovoltaic cells integrated with building. We can integrated PV with roof integration, phase integration, and sun protection building. And these slides show how can integrated photovoltaic cells with the window of the building and combination with glass to one unit. This slide shows grade on system. This type of solar field need large area to spread units in it, such as the desert and open place to spread them. Slide show how can architecture design integrated photovoltaic cell with building. This process of design the integrated energy of the building must include the following activities beside the traditional architecture design and construction stage. Integrated design of the building through content and cooperation planned by the building and owner design with a clear goal setting for the building design and project costs. Simulating the building energy performance through electronic system to help the designer to take better solution about the properties and components of building outer cell. Learn about the efficiency of using the laser energy technology in the building to give option and opportunity for the designer to design energy efficiency strategy of the building, understanding the general climate of the project site with help to design the climate environment of the building to be responsive the general climate with help to realization energy consumption in the building. Here we see how solar cells merge with different types of buildings. Case study. Building orientation is optimized with minimal direct west facing phase 50% to reduce solar heat gain. Computational fluid dynamic analysis is carried out to optimize natural wind flow through the development. Sun shading devices are provided on the northwest to southwest facing opening. Approximately 60% of the roof area is covered with a combination of PV panel and extensive green roof system. High performance building envelope designed with a host of environmentally friendly features including high energy efficiency cooling planet, innovative heat pipe technology to reduce the cooling load of the air conditioning system, recycling of condensate to save water, thereby reducing the carbon footprint of the building, energy efficiency fluorescent light with electronic bulbs are installed in the building, motion sensor connected to the height in the toilet reduced. The GATE project solar photovoltaic building integrated photovoltaic are used to replace conventional building material in part of the building envelope such as the roof, skylight, or face. The advantage of integrated photovoltaic over more common integrated system in that initial cost can be offset by reducing the amount spent on building materials and labor that would namely be used to construct the part of the building that PIPV model replaced. Transparent solar panel use a tin oxide coating on the inner surface of the glass panel to conduct current out of the cell. The cell contains titanium oxide that is coated with photovoltaic dye. In this part discussion, how to develop photovoltaic cell by nanotechnology. Interpenetrating nanostructured network. Degeneration multi-junction cell. Organic photovoltaics convert sunlight into electrical power. Nanotechnology solar cell design. By synthesized solar cell. Future generation printable cell. Solution processable semiconductor. Organic cell nanostructure cell. Nanowire applications for solar cell. Nanowire decouple light absorption and carrier extraction into different directions. It was also reached to produce organic cells from natural materials. One of their advantages is to reduce their production costs, even if they are less efficient than silicon cells. It was also reached to produce plastic photovoltaic cells in the form of soft roll, and they can be placed on large areas such as roof of buildings. It was also possible to reach the types of cells that can be merged with the glass interface curtain walls in various colors and shapes, and they become an important structural element of the building. Also, through nanotechnology techniques, it is possible to develop photovoltaic cells through green chemistry and changed the properties of the materials that make photovoltaic. It is possible to raise the efficiency of photovoltaic cells and the efficiency of silicon cells. The issue of energy and its relationship to building, which is known as the sustainability of building discussed in the research, is not considered a manifestation of luxury, but it is a fundamental issue related to the economics of countries and their human development. And the energy issue is an urgent issue at the present time that all countries try to provide energy sufficient to meet their multiple needs of the population. And the more the number population increase the need for energy, we find that energy is based on all human activities, as it is the main nerve of contemporary life. Just as food is the fuel of human life, so electrical power is one on which people depend for all daily activities. And with a comprehensive view of energy sources, we find that the world has tended to generate energy in previous era on non-renewable resources, which are called unrenewable energy resources. On them, with all their capability, if we consider the work photovoltaic cells from generation of electrical current from natural resources, we find that they are similar a natural process that takes place in planets in the field and it repeated dozens of times. A process of photosynthesis that takes place in the planet at night where the planet absorbs carbon dioxide from atmosphere, then the chlorophyll that is found in the leaves of planets performs photosynthesis. The result of this chemical process results in the release of oxygen gas and release of energy from the planet. If we liken the planet to the building, the photovoltaic cells represent chlorophyll in the planet, where photovoltaic cells absorb the solar radiation. Some atoms move from their orbits in other orbits, and this process is called induction, which results in the generation of an electric current. Here we find the importance of studying the environment in component and its natural process and how to benefit from its application in other areas. There are studies specific to the designer and the design process of building to apply the integration photovoltaic cell in them. There are many factors that must be taken into account before starting the design process, the most important of which are the location of building, the topography of the earth, the distance between the buildings, the height of buildings, the direction of building, the climate factors on the site, a study of the building's interface that are exposed to solar radiation. Here, where the PV cells can be placed. The architect uses the success of the design process with multiple tools such as climate program and the impact of climate factors on the performance of building, as well as imaginary performance program simulation that show the most important phase of building influenced by solar radiation, period of sunshine, and so on. By studying the entry of photovoltaic cell in the field of building materials, we find that they have multiple effects. It is an important design tool for the architect. If we linked the energy engineer to the artist who take his brushes and draw his artistic painting, and there is a palette of color, the photovoltaic cell represent a new tool that the artist can produce his painting in the best possible way from the formal and functional point of view. Photovoltaic cells have multiple properties. They represent a source of electricity production. There are also a thermal insulator for the building, and acoustic insulator, and an insulator from the sun rays if they integrated with glass. Finally, it is structural factor for building phase where it is possible to provide photovoltaic in multiple color and shapes. Also, the planner must choose the system that are applied at the level of city planning and which situations are most suitable for their application. There are systems called grade-off in which the photovoltaic cells are placed directly on the buildings and the solar rays are converted into the electrical current, and there is a transformer to convert the continuous current generated from the cells to alternating current that can be used directly for multiple. I would like to thank you for attention.